Right, so first up is Dr. Rob Lake. So Rob, if you want to turn your camera on so we can see you. Rob's going to talk to us about a national Listeria database. Rob is my colleague at ESR. He's the manager of risk assessment and social systems, a group that's based in Christchurch. And his speciality is food safety risk assessment and public health, including burden of disease. And I just want to say a particularly huge thank you to Rob for a really important role he's playing right now in providing intelligence from ESR to the Ministry of Health on COVID-19, particularly the wastewater epidemiology results. So he's the guy that stands at the pivot of things flowing from ESR through to Ministry of Health, which keeps him out of trouble in his evenings and his weekends. And he's also recently been appointed to the chair of the World Health Organization's Foodborne Disease Burden Epidemiology Reference Group. So we're very lucky to have Rob with us today to talk to us about the National Listeria database. And now to share your slides.
Yeah, can you hear me okay?
We can.
Okay, I'm going to try and share the screen here.
Yeah.
So does that come up?
That has come up.
Okay. I apologise in advance. There may be some little pop-ups in the corner of the screen. I haven't figured out how to turn off Teams notifications. So, right. So today I'm going to be talking about the status of the whole genome sequence database that we have for Listeria monocytogenes in New Zealand and its use for bacterial tracking. Many of you will have seen the initial material, the description of the database, but I thought I would just cover that for people who are new and might be a useful refresher for some people. So the database was established about 2 to 2.5 years ago. And the concept behind it was that it was a shared database to realise the benefits of collating whole genome sequence data to enable comparisons and promote understanding of the population genomics of Listeria in New Zealand. Sources of isolates that could be sequenced and existing whole genome sequence data were approached about adding their data into the database. And ESR led the project and was established as the custodian of the database. And we negotiated with the Ministry of Health about including sequence data from clinical isolates. We worked with the Ministry for Primary Industries on securing isolates and data from projects that they'd conducted. And we also negotiated with a number of different food companies to both secure data and isolates for further sequencing. So each of these sources agreed to include information in the database, which was set up as a resource, and the intention was to share the data under conditions of use. And so in terms of sharing the data and the conditions of use, we realised very early that there were benefits and risks here. And I believe this information was collected by a study by the University of Otago, consulting with companies and regulators about the benefits and risks. And so obviously with the benefit is we can have cross-sector information, looking at a wide range of strains. We were very interested in the diversity, commonalities and persistence of strains in the environment. And we wanted to facilitate knowledge and best practice sharing across industries. And the comment at the bottom on the left there is a very important issue about providing context for the strains of Listeria, particularly about how common they are and or whether new strains are emerging. In terms of risks, there was concerns about accessibility of the data. if this data is shared and people can make connections between clinical data and food sources, then there's a danger of reputational damage and possibly commercial problems. So we were quite mindful of trying to develop the database in a way that managed these risks. So the database was set up to minimize the risk and promote sharing of data. So we were very careful to ensure that the data was secure and that permission had been obtained for any data that was included. We created a research electronic data capture system for managing the data and providing access. And this tool enables us to create data access groups and assign user rights and restrictions to view selected information. So controlled access was very much in our minds as we developed the database. So once a user is logged onto the database, they can see a listing of all the isolates in the database with metadata. And we worked quite hard to establish a set of metadata that was a minimal data set that was pretty much agreeable to all the users without providing too much specific information. So I think you can see there that each isolate has an individual identifier, species is named, fairly straightforward, the serotype is given. The sample type is restricted to only two categories. We define isolates as either clinical or non-clinical, and that's the level of detail that we go into. Country, New Zealand, and the year in which it was isolated are also given. On top of that, there are a number of other pieces of data specific to the isolate and the source, particularly the sequence type, the sublineage, and some further information about the codes, the allele codes, the typing information. So at the moment we have just over 1,000 isolates in the database, and they're about 50-50 between non-clinical and clinical isolates. The way the database is set up, it enables clients to identify their own isolates amongst the others, and the data can also be filtered and sorted. I should point out at this stage that clinical isolate information is subject to a 12-month stand-down. So we only include clinical isolate information after a 12-month period. So it's always 12 months old. Oops, sorry. So during a session, users can upload additional information, which can assist them with their own analyses and interpretation of the data. This is private information that's not saved, and it's deleted after a session is terminated. And the information is for only their view. This data can also be incorporated into the phylogenetic trees, which are can be created using a built-in tool, PhyloCanvas. So in summary, the database includes a minimal metadata set. Users with isolates in the data can view restricted data, which is the isolate ID and the submitter. And a user can also upload additional data, which is potentially useful for analysis, but is not saved. And the isolates can be selected to analyze and compare on phylogenetic trees. So that's a fairly brief overview of the current status of the database. So I just discussed some of the values of whole genome sequence data and reasons why this database is valuable. Whole genome sequence data is being adopted as the technology for disease surveillance and outbreak detection at a national level for public health. And databases of clinical isolates have been established both at an international level, and also a number of countries have established dedicated databases. China has the TRANET network, which is nationwide. Public Health in England has been sequencing clinical isolates for a very long time, focusing particularly on Salmonella and STEC. In the US CDC, the PulseNet network has, in the last few years, transferred from PFGE to whole genome sequence for typing of the clinical isolates that they have. There is another database in the US called Genome Tracker, which is a database owned by the Food and Drug Administration. This database includes information from food-sourced isolates from monitoring programs run by the Food and Drug Administration. In Australia, they're working towards a unified system based at the University of Melbourne, and it has the name AusTracker. And in New Zealand, ESR has an in-house database which collates all the information from clinical isolates that we receive mostly through the enteric reference laboratory. So it's a widely adopted international tool for public health surveillance. The reasons for adopting whole genome sequence for industry are that detailed information can be obtained on the isolates originating from industry. And this can act as insurance relevant to recalls and potential linkages, which can either be ruled in or out as to whether there is a linkage, but also can be informative about contamination sources if the location from which an isolate was obtained is included. It's a track and trace tool to guide contamination management. And it's also, and this goes back to the context point that I made earlier, that it provides baseline data to identify new strains and potential entry points. So we've been discussing the value of whole genome sequence information to industry members, and we've got a few quotes here which I hopefully indicate the value that industry have been able to obtain. It's not a solution itself, but it's a tool to provide evidence for decision-making around pathogen management. Interpretation of genomic data can be a particular skill, and on-site workshops have been held with scientists to understand and interpret the data. And whole genome sequencing can be useful to determine both the existence of a contamination and also potentially whether it had been resolved. So just going a bit further with this topic, whole genome sequence information can be part of confirming that systems are in place to prevent entry of new strains to the factory. It's a component of good food safety culture. It assists analysis and learning from incidents, and can also provide insight into the phenotypic characteristics of the strains that have been isolated. For example, genetic data can be used to inform about potential for antimicrobial resistance or heat and sanitizer resistance. So what's next? This database was created under a 4-year planned program, and we're currently in year 3. The program was funded upfront, primarily with government funding, with the intention that as industry came on board, then the funding sources would shift. There is a meeting planned by the Food Safety Science and Research Centre with industry. It's planned for early November 2021. ESR will continue in its curator role, and we will collate further whole genome sequence data from clinical and food sources where we're able to, with permission from those sources. And we anticipate that there will be probably a small effort in maintaining that curator role for the future. What we'd like to do now is focus on the database as a resource for industry. We'd like to develop mechanisms for industry to extract information from data from their own isolates and use that to provide additional information for risk management. The kind of tools that we're thinking about are comparison tools, obviously looking at phylogenetic trees using either MLST or SNP analyses. We'd be interested in mapping tools for temporal and spatial location of isolates. One such tool is called MicroReact. We need to be a little bit mindful that some of these mapping software tools may be proprietary, and we need to be careful about using them. I mentioned that there is a stand-down period for clinical data. The data from clinical isolates, the Ministry of Health is now given the ESR permission to upload that data to international databases tracking whole genome sequencing internationally. But that data is subject to a 12-month stand-down, and ESR has adopted the same policy for this database. We were wondering whether a stand-down periods for industry data might give them a greater level of comfort for the potential risks. We had a question about whether industry wanted to extract and analyse their data completely separately, or whether they wanted to tap into specialised expertise from the science providers that are members of the Food Safety Science and Research Centre. And finally, we're aware that sharing data and more detailed metadata from the food industry can be or needs to be handled in a confidential way, and mechanisms need to be set up to achieve that measure of confidentiality and to create an environment in which the data can be shared with trust on both sides. And we're aware that although the scientists bring a lot of specialised knowledge around genomics and typing, understanding the intricacies of food processing operations and plant operations is something that we often don't have, and so the interpretation of this information needs to be a partnership. So that's what we've been thinking about. We're hoping that people will bring some ideas and be willing to participate in the meeting that's scheduled for November. So in conclusion, I just want to acknowledge in particular Lucy Rivas, who's provided many of the slides here and who also has been leading the project from its inception, and also to acknowledge the funding that's been provided by the Food Safety Science and Research Centre, and ESR's Strategic Science Innovation Fund has also contributed support to develop the database. So I'd like to open the floor for any questions. I'm kind of hoping Lucy's on the line, that she can answer the trickier ones. Thanks.
So Rob, unfortunately, thank you, Rob. That was a really interesting presentation. And I know some of the challenges that you and the team have gone through with respect to ensuring that cybersecurity protocols were upheld from the ESR end. So thank you to you and Lucy. Unfortunately, Lucy's not allowed to speak. Only the panelists and myself and Cass can. So Lucy, you'll have to maybe type into the Q&A if she's got some contributions, and also acknowledging Lucy as a member of the ESR team who's done a lot of work here. So we do have some questions popping up, and I'll read them to you. First one is from our friend Peter Cressy. Any unexpected Listeria clusters identified so far?
The answer is no. I think there was one historical linkage from a few years ago that was found, but by and large the answer is no.
Okay, Thank you. And then Lisa Savo has a question about uploading session data. So can a user upload session data and give permission for another user to see that?
I can't actually answer that question. That would be a function of the database software, and I'm not familiar enough with that to answer that question. I think if you wanted an answer to that, I think you could probably email Lucy, but I'm sorry, I can't answer that.
Okay. Or email through to the Food Safety Science Research Centre, and they can pass it on to Lucy. And then final question on the chat, although Kath or I may have a question for you, is from Craig Shadbolt. And Craig asks, is there a danger that the stand down periods compromise the effectiveness of the database?
The database, in terms of the clinical data, 12 months stand down, that is the intention of the database is not to be a public health surveillance tool. There's a separate database that ESR holds that fulfills that public health function, and that's, you know, right up to date. For the purposes of the database, I think the stand down period is up for discussion. I think the stand down for clinical data is a protection against perceived risks about current linkages being found, and the stand down periods for industry data, I think, is up for discussion. It's one option that we thought of that might encourage people to contribute data, but it's by no means a given, and we obviously would like to keep the data as up to the minute as possible.
Thanks, Rob. Oh, there's another question popped into the Q&A from Alison Turnbull. Thank you, Alison. Do you have an idea of what percentage of industry approached are using the database? Keen to understand how many industry members are using this option.
Well, we have put out the invitation to all industry members who are part of the Food Safety Science and Research Centre to participate, and additional members would be welcome. So that, you know, all of the industry members of the centre have been approached or invited to use the database. I think I hadn't really thought to that. Maybe half are participating at the moment. Yeah.
Okay. Well, thank you, Rob. And that's the end of the questions. And